Okay, let's go back to that unit circle, and we're going to pick a generic point on that circle. So there's a number of different points that we could pick on a circle. We're going to pick a generic one. We're going to call it XY. I'm drawing it in the first quadrant for make it easier to sort of visualize, but we could have drawn it in any of these quadrants. And then what I'm going to do here is I'm going to actually create a right triangle. So I'm going to take a, over here, I'm going to go ahead and drop down a vertical line here, okay, to make a 90-degree angle. Okay, and so now I have a right triangle. And if I'm paying attention here, the height of this right triangle is just whatever that y coordinate is, because I went up y. I mean, that's what the y coordinate means. And the horizontal piece is whatever that x coordinate is. And if I just look at this and do a little Pythagorean theorem, I would note that x squared plus y squared would have to equal 1. The hypotenuse squared, or 1 squared. But moreover, I can actually find, if I want to talk about this angle here, I can find trig values for them. So the sine of theta, the cosine of theta, and the tangent of theta. Now, for those of you who've forgotten, because it's been a little while since we've done this, here's our little handy-dandy acronym, SOHCAHTOA. Okay, so sine is equal to the opposite side divided by the hypotenuse. That's what the SOH is for. So if I look at my angle, opposite is y. So y here is my opposite. Okay, the hypotenuse is the longest side. It's 1. That's my hypotenuse, which means that x here is going to be my adjacent in all these. Okay, now sine is the opposite, which is y, divided by the hypotenuse, which is 1. So in other words, in this unit circle, well, this is nice, y divided by 1, that's just y. That means that in a unit circle, the sine of theta is the y coordinate. Okay. Cosine of theta, well, cosine is adjacent divided by hypotenuse. Adjacent is x divided by hypotenuse is 1, x over 1, well, that's just x. So the cosine of theta in the unit circle is the x coordinate on that unit circle. Okay. And then last we have tangent. Tangent is the opposite, which is y, divided by x. So tangent is the y coordinate divided by the x coordinate. All right, I'm going to stop here. I'm going to pull up the actual unit circle, and we'll find the sine, cosine, and tangent of various angles using the unit circle. Okay, here we are. Finally, I'm going to use this unit circle to find the exact values of trig ratios, and it's actually fairly simple. And then, of course, as pre-calculus, it's going to get complicated, but it won't be too bad. All right, so if I want to find the sine of 225 degrees, first I go to my unit circle and find, well, there's 225 degrees. And the sine, if you remember from the last section, the sine is the y coordinate. So I go and I look at the coordinates at 225 degrees, and the y, the second one here, is negative root 2 over 2. That's it. That's my answer. The sine of 225 degrees, according to the unit circle, is negative root 2 over 2. If I go to the cosine of 150, so I find 150 degrees, it's right there. I find the coordinate point that, oops, that's the wrong one, not that one. This one is connected to it, okay? And cosine now, I'm looking at the x, so I don't worry about the y coordinate. I just look at the x coordinate, and that is negative root 3 over 2. And I'm done. Okay, so sine is looking at the y coordinate at that angle, cosine is looking at the x coordinate. That's it. Now tangent requires you to divide the y divided by the x. So if I go to 240 degrees, let me use a different color here. This is 240 degrees right there. And so here is the coordinate point, and I have to take the y. So negative root 3 over 2 divided by negative 1/2. And immediately everyone freaks out. But here's the deal. If I'm dividing two things that are both have the same fraction on the bottom, the same denominator, those denominators are going to cancel. And so all I really am doing is dividing the tops, which is negative root 3 divided by negative 1. Negative divided by negative is a positive, and root 3 divided by 1 is just itself, root 3. And so there you go. There's a tangent of 240 degrees. All right. Now, as I said, this sort of starting point is pretty simple. And it gets a little bit more complicated. So let's show you how that works. First, let's see what happens when I have a tangent, such as the tangent of 30 degrees. So here's 30 degrees, okay? And we're going to go ahead and take the y-coordinate, which is 1/2, and divide it by x-coordinate. And you know what? We can cancel those bottoms, and that leaves me with 1 over the square root of 3. There's a problem, though. That's not correct math form. We can't have a square root on the bottom. And so we're going to need to multiply the top and bottom by that square root, and that will give me, on top here, I'll have the 1 times the square root of 3, the square root of 3, and on bottom, when I multiply a square root by itself, I mean, that's the whole point of a square root. What number times itself is the thing inside? The square roots cancel, and I'm left with just 3. And so that would be proper form, the square root of 3 over 3. Now, I'm going to give you a little bit of a shortcut here. Say I have 2 divided by the square root of 5, or another example, 4 divided by the square root of 7, or another example, 5 divided by the square root of 5, or one more, 8 divided by the square root of 2. I can actually kind of do a shortcut here, and that is to get rid of the square root on the bottom and just multiply the top by that square root. So I'll show you. And this is a shortcut for whenever you're dividing by a square root. This is equal to 2 root 5 over 5. So the square root went away, and on the bottom, and on top, it got that square root. So this one is equal to 4 root 7 over 7. And this one is equal to 5 root 5 over 5. And those 5's, because it's division, those would cancel. So it's actually just equal to the square root of 5. Let me circle that a little better. And then this one here would be 8 root 2 over 2. But 8 divided by 2 is 4. So this would be 4 root 2. Okay, so there's a sort of a shortcut. And you're going to need that shortcut here because things are going to get a little bit more complicated. Okay, now let me erase all this stuff I just did. And we're going to come back to some of these problems that we did before, but we're going to use now new trig functions that we really haven't seen before. And that is, so we've had sine, okay, cosine, tangent, and now we have cosecant, secant, and cotangent. Okay, now their abbreviations are all 3 letters. So they all have 3-letter abbreviations. So sine, cosine, tangent, you've seen. Here are cosecant, secant, and cotangent. So if I were to go back to what I had before was I was asked for the sine of 225. This time I'm going to ask for the cosecant. And last time I was asked for the cosine. This time I'm going to be asked for the secant. And last time I was asked for the tangent of 240. Now I'm going to ask for the cotangent of 240 degrees. All right, now, here's the deal. I wrote these in this order because sine is the reciprocal or the flipped over version of cosecant. And cosine is a flipped over version of secant. And tangent is a flipped over version of cotangent. All right, I'll show you how that works here. Okay, so let me write that down again. Sine of an angle is equal to 1 over cosecant of that angle. And vice versa. Cosecant of an angle is 1 over sine. Cosine is 1 over the secant. It's a reciprocal, so secant is 1 over cosine. And tangent is 1 over cotangent. And vice versa, cotangent is 1 over tangent. So what that means is any fractions that I see, I'm going to flip over. So this first one, cosecant, we're going again to this 225 degree angle, and we are still looking at that y coordinate because it has to do with sine. Cosecant has to do with sine. But it's the flipped over version. So instead of writing this number, negative root 2 over 2, I flip it over negative 2 over root 2. Negative 2 over root 2. And we'll come back to that. If I were to go to secant, secant is the reciprocal of cosine. So again, back to this 150 degrees, but instead of writing negative root 3 over 2, I write negative 2 over root 3. And then lastly, cotangent, instead of taking the y and dividing the x, so here at 240 degrees, I'm going to take the x, which is negative 1/2, and divide it by the y, which is a negative root 3 over 2. Now, as you can see, all of these have square roots in the bottom, so our handy dandy shortcut is going to help us a lot. So this is going to be equal to negative 2 root 2. Square root goes in the top, square root disappears in the bottom. Okay, this one here, negative 2 root 3, square root goes in the top, disappears in the bottom. In this one here, the 2's are going to cancel. A negative divided by negative is a positive, so I have 1 over the square root of 3. Oh, I need to put that square root on the top. So I could write 1 root 3, but I don't need that one. Okay, and then it disappears on the bottom. And so there you go. And that's how you use the unit circle. Now, there are going to be some challenging problems towards the end that will ask you to find angles that aren't written on your unit circle, such as negative 630 degrees. Well, in this case, you need to kind of critically think. Negative means I'm going this direction. This would be 360 degrees. And I need to keep going until I get to negative 630, which would be another 270, and I end up right here. And so whatever I'm looking at, I'm using this coordinate point at the top. So there are some sort of challenge questions at the bottom. This worksheet that we've been working through here is called Exact Trig Values of Special Angles. All right, so there you go. It gets simple to start, gets tough as you move through it, but that's how to use the unit circle to find exact values of trig functions.